why your plant dies from the bottom up first. When the oldest leaf on your plant turns yellow, you probably think, that's just an old leaf, so you remove it, you water less. Maybe you add fertilizer, and you move on. But here's the problem. A lower leaf turning yellow is not a diagnosis, it's a distress pattern. And the same pattern can be produced by completely different problems. Too much water, too little water, nutrient depletion, too much fertilizer, pests, root restriction, disease, poor water quality, cold stress, or nothing at all. Sometimes it's just the plant letting go of a leaf it no longer needs. The real question isn't, why is the bottom leaf yellow? It's, why did the plant decide this tissue could be sacrificed? Because the plant is constantly triaging resources, and by reading the pattern, the roots, the substrate, the water, the environment, and the newest growth, you can determine which mechanism is actually driving the decline. By the end of this video, you'll have a full diagnostic protocol that tells you whether to water, dry, feed, flush, repot, treat, or do absolutely nothing. But before you touch that yellow leaf, you need to understand why plants sacrifice their oldest tissue in the first place. The bottom leaves are usually older, and older leaves are often less valuable to the plant's future architecture than actively developing tissue. So when resources become limited, the plant can remobilize mobile nutrients from older leaves. Nitrogen, phosphorus, potassium. These resources move toward higher priority sinks. The shoot apex, young leaves, developing tissues. It's biological triage. That is why bottom-up decline is so common. But here's the trap. The same triage mechanism can be triggered by almost a dozen completely different problems, including no problem at all. Start with the branch most people skip. Sometimes a lower leaf is simply old. It's shaded out by new growth above it. It's no longer photosynthesizing efficiently enough to justify its upkeep. Or the plant was recently moved to lower light and is shedding leaves it can no longer afford to support. This is not a crisis. One leaf, slow, even yellowing. No other symptoms, strong new growth continuing above it. If that's your plant, stop diagnosing. Just let the leaf go. But if more than one leaf is involved, or the pattern accelerates, keep investigating. Now the real problems begin. In an aeroid grown in a dense or chronically saturated mix, water can displace the air in the pore spaces. Oxygen diffusion through water is dramatically slower than through air. Root respiration becomes impaired. Under severe, prolonged hypoxia, roots can lose function and tissue can die. The plant's supply chain starts collapsing, and only later. You see the lower leaves yellow. This is the classic. The roots failed first. But don't stop there, because if your plant is yellowing from the bottom and the substrate is bone dry, you may be looking at the exact opposite mechanism. Underwatering creates a different crisis. Water availability falls. Root zone water potential declines. The plant begins protecting its most valuable tissues. Stomata close, growth slows, and older leaves may be sacrificed to reduce total water demand. The visual result can look surprisingly similar. Lower leaves yellow, then brown, then drop. But the diagnosis is opposite. If the root ball is consistently drying too far between waterings, adding more drainage could make the problem worse. The plant doesn't need less water. It needs a more stable water supply. Now consider nitrogen. Nitrogen is highly mobile within the plant. When supply is inadequate, the plant can remobilize nitrogen from older leaves. That creates a familiar pattern. Older leaves become progressively pale, then yellow, while newer growth may remain greener, at least initially. With nitrogen deficiency, the root zone may have perfectly adequate oxygen. The plant may not be overwatered. There may be no pathogen. The problem is simply that the plant cannot acquire enough nitrogen to maintain its tissues. But be careful, because the opposite mistake is just as common. Here's the branch most people never check, because they assume more fertilizer always helps. Repeated feeding without flushing, or overconcentrated fertilizer, can cause dissolved salts to accumulate in the substrate. That raises the osmotic pressure around the roots. making it harder for the plant to absorb water. Even when the substrate is technically moist, the visual signature is different from nitrogen deficiency. Nitrogen deficiency tends to look like uniform, even paling across older leaves. Salt injury tends to look like crispy brown leaf tips and margins, sometimes with a visible white or crusty buildup on the substrate surface or pot rim. If you've been feeding heavily, and the lower leaves are burning at the edges rather than fading evenly, stop fertilizing. You don't have a deficiency, you have a buildup. The lower leaf is the report, not the diagnosis. So now we need to investigate the other suspects. The diagnostic tree expands further: pest icon, root-bound icon, pathogen icon, repot icon, water droplet icon, thermometer icon. Because sometimes the roots aren't drowning, the plant isn't starving, the plant is being attacked, or it's simply sitting in the wrong water, or the wrong temperature. Spider mites, scale, mealybugs. Sap-feeding pests can cause chlorosis, especially when populations become significant. The mistake is treating every yellow lower leaf as a root problem. Inspect the underside, check petioles, look at nodes, look for stippling, sticky honeydew, cottony masses, scale shields, fine webbing. If the evidence is on the plant, not in the root zone, stop changing your watering schedule. You have a pest problem. Now consider a plant that's physically outgrown its container. The roots may be healthy, but tightly packed. Water distribution becomes uneven. The substrate may dry rapidly in some zones. While the center remains wet, the plant can become increasingly difficult to hydrate consistently. That's root restriction, not root rot. The solution isn't automatically a fungicide, and it's not automatically more water. Sometimes the plant needs a correctly timed repot into an appropriately sized container with a structurally stable substrate. And here's another distinction. Root rot isn't one single disease. Waterlogging can weaken roots, but pathogens such as Pythium, Phytophthora, and Fusarium can also be involved in root and crown decline. Improving drainage may correct the environmental trigger, but it may not eliminate an established pathogen. If roots are rapidly collapsing, if the crown is affected, or if decline continues after environmental correction, you may be dealing with an infectious problem. That requires a properly labeled fungicide or biological control appropriate to the pathogen. And then there's the scenario that causes panic in collectors. You buy an expensive plant, you repot it, 2 weeks later, the oldest leaves begin yellowing. You assume root rot. But transplant shock can temporarily reduce functional root capacity. The canopy is still demanding resources, while the root system is recovering. If the newest growth remains healthy, and the root system is stable, don't keep repotting. Repeated disturbance can turn temporary stress into permanent root damage. Sometimes the problem isn't how much water, it's what's in it. Fluoride-sensitive plants, like certain Dracaena and Calathea relatives, can develop tip and margin necrosis from fluoridated tap water over time. Hard or highly mineralized water, or water softened with sodium, can contribute to salt accumulation in the substrate, compounding the exact injury pattern from branch 4. If you've ruled out overfeeding, but you're consistently using hard, softened, or fluoridated tap water, and the pattern is chronic tip burn rather than sudden decline, consider your water source as a contributing branch. Rainwater, distilled water, or filtered water can reduce the risk for sensitive species. One more suspect before we build the matrix: cold drafts, sudden temperature drops, proximity to an air conditioning vent or a drafty window. These can stress root and leaf tissue independently of moisture, nutrition, pests, or disease. The pattern often includes lower or perimeter leaves, especially those closest to the cold source, declining faster than the rest of the plant. If nothing else fits, check where the plant is sitting and what it's sitting next to. Because the fastest way to lose an expensive plant is to treat the wrong branch before watering, before fertilizing, before repotting. Answer 6 questions. 1. How many leaves are declining and how fast? One isolated old leaf over weeks is different from several leaves collapsing within days. 2. What does the newest growth look like? Healthy new growth is a strong positive signal. Distorted, stalled, or rapidly declining new growth is more serious. 3. Is the substrate wet, dry, or somewhere in between right now? Don't guess. Check it. 4. Is there any visible evidence on the leaves or stems themselves? Stippling, webbing, scale, crusty residue, or margin burn all point in different directions than root causes. 5. What changed recently? Repotting. Location, light, temperature, fertilizer routine, water source. 6. Where is the plant physically sitting? Near a draft, a vent, a cold window, or in front of an air conditioner? The timeline and the environment often reveal the cause before you ever touch the roots. Use a moisture meter appropriate for your substrate, but don't worship a single number. Sensor readings vary dramatically between devices and media. Instead, calibrate the tool. Measure your plant when the substrate is freshly watered. Measure again when the plant reaches your normal rewatering point. Record both. Then compare the reading with actual pot weight and plant behavior. You're building a plant-specific moisture window for aeroids and chunky mixes. The correct target will not be the same as for a dense peat-based mix, and neither will match a succulent. While you're at it, check your water source. If you're using hard tap water, softened water, or know your area has high fluoride content, and you're growing fluoride-sensitive species, that's worth noting now before you start changing anything else. If the root ball is chronically saturated, stop treating the leaves. Address the environment. Remove the plant if inspection is warranted. Identify living roots versus clearly dead or rotting tissue. Use sterile cutting tools to remove severely compromised tissue. Do not aggressively remove every discolored root automatically, then repot into fresh, structurally stable substrate appropriate for the species. For many aeroids, a chunky mix using components such as bark, pumice, and an appropriate moisture-retentive fraction can maintain both moisture and airspace. The exact ratio depends on your environment. Humidity, pot size, light, temperature, and watering frequency all factor in. The objective is simple: enough water to hydrate, enough air to respire, enough structure to maintain both. If a pathogen is suspected, don't assume drainage alone is a cure. Isolate the plant, remove clearly diseased tissue, and use a properly labeled treatment only when appropriate to the suspected. Don't assume drainage alone is a cure. Isolate the plant, remove clearly diseased tissue, and use a properly labeled treatment only when appropriate to the suspected pathogen. If the root ball is consistently drying too far, your problem is different. Increase watering consistency. Evaluate whether the container is undersized. Check whether the substrate has become hydrophobic. Look at environmental demand. Higher light, higher temperature, and active growth can dramatically increase water consumption. The solution may be a more moisture-retentive substrate, a larger container, more frequent watering, or a combination. Don't automatically add more pumice. Don't automatically increase drainage. A plant cannot thrive in a root zone that repeatedly swings from saturated to bone dry. Stability is the goal. If the roots are healthy, moisture is appropriate. Pests are absent. Nutrition moves higher on the suspect list. But check which direction you're dealing with. For suspected nitrogen deficiency, look for broad, even chlorosis on older foliage, not just one isolated yellow leaf. Use a complete fertilizer containing nitrogen, rather than blindly increasing one nutrient. Start conservatively and follow the product label. For suspected salt or fertilizer injury, do the opposite. Stop fertilizing. Flush the substrate thoroughly with plain water to leach excess salts, allowing it to drain completely. Check for crusty white residue on the substrate surface or pot rim. Reduce feeding frequency or concentration going forward. The goal in either direction is the same: adequate nutrition, without deficiency, and without buildup. If you find pests, use a treatment appropriate to that pest. Repeat according to the product's label and life cycle. Don't expect one application to eliminate an entire population. If you suspect a pathogen, treat the environmental cause, but don't pretend environmental correction is always sufficient. Isolation, sanitation, removal of severely affected tissue, and a properly labeled fungicide or biological control may be necessary. The treatment must match the agent, not the color of the leaf. If tip and margin burn persists despite correct watering and fertilizing, and you know your water is hard, softened, or fluoridated, switch to rainwater, distilled water, or filtered water, especially for sensitive species. This is a slow-acting cause, so give it several weeks before judging results. If the decline is concentrated on the side of the plant nearest a vent, a draft, or a cold window, relocate the plant before changing anything else. Sometimes the fix isn't the water schedule, it's the water itself, or where the pot is sitting. Here's your final diagnostic tool: time. After correcting the suspected cause, stop making random changes. Observe for roughly 2 weeks under stable conditions. You're looking for trajectory. Does new growth continue? Does the rate of decline slow? Does the substrate dry more predictably? Do roots remain firm? Does the plant stop sacrificing additional leaves? One old leaf may still fall. That's not automatically failure. The question is whether the plant is still losing ground. The best recovery signal is often not the damaged leaf. It's what the plant produces next. Now you know how to read it. Rapid montage, yellow lower leaf, saturated roots, dry root ball, nitrogen pathway, salt crust, spider mite, root-bound plant, pathogen, water pouring from a filtered pitcher, a plant moved away from a cold window, healthy new growth. So why does your plant die from the bottom up first? Because the plant is often protecting what it considers more valuable. When resources become limited or conditions turn hostile, older leaves can be sacrificed. But the reason those resources became limited can be completely different from one plant to the next. The roots may be drowning or dehydrated. The plant may be nitrogen deficient or overfed. Pests may be draining it. The roots may be physically restricted. A pathogen may be destroying the supply chain. The water itself may be the problem. The temperature may be the problem. Or the plant may simply be recovering from a recent repot, or letting go of a leaf it never needed in the first place. Same symptom, 11 different mechanisms, 11 different treatments. That's why you should never diagnose a plant by the yellow leaf alone. Read the pattern, read the timeline, read the roots, read the substrate, read the water, read the environment, and most importantly, read the newest growth, because the plant is constantly telling you what it needs. You just have to stop listening to the symptom and start reading the system. And if you've ever had a rare plant suddenly produce a tiny, pale, or deformed new leaf, don't assume it's just a bad leaf. That symptom can reveal an entirely different failure inside the plant's vascular system.